10.5, testing convergence at endpoints. So I can't show you how to test convergence at endpoints until we discuss what's going on with this 1 over n thing. So ratio test, yay, oh, I love the ratio. No, I don't. All right, so limit as n goes to infinity, 1 over n squared. So we go with 1 over n plus 1 squared divided by yada yada, n squared, which is 1. All right, n squared over n squared, 1. So that's inconclusive. Interesting. Well, what if we do this one? Limit n goes to infinity, 1 over n plus 1 times n. 1. Inconclusive. Whew. It's nerve-wracking. I didn't know if I was going to make it there. Well, I'll tell you the end of the story here. I know this one converges. And I know that this one diverges. At which point you're like, yeah, but the ratio test didn't do it for us. Yeah, I know. It happens. That's why that whole one thing is there as inconclusive. All right. Well, let's back up. How about just do the whole integration. We'll go from 1 to infinity because it's 1 over 1 is the first term. You might argue, no, it's 0, whatever, I don't care. All right, so this is 1 over n squared or 1 over n. N squared will have a steeper decline. And we're trying to figure out all this. All right, well, let's try it with 1 over n squared. So the integral from 1 to infinity of 1 over n squared dn is all this nonsense. A goes to infinity. The only reason I don't mind rewriting it this time is because it's going to be n to the negative second. And then we go equals negative 1 over n, right? Limit a goes to infinity from 1 to infinity, which is negative 1 over infinity minus negative 1 over 1, which is 0 plus 1, 1. Cool. If we do it for 1 over n, of course, we get equals infinity minus 0 equals infinity. Don't agree with me? Go back to unit 9 and look, because we did it then. So this one converges to 1. This one diverges. The ratio test didn't help us, so this is called the integral test. Okay, so be it. So it's some n value to infinity. I used 1. You compare them, blah, 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 sum, blah, 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 the integral and the sum, blah, blah, blah. They either both converge or they both diverge. We just showed it. If they converge, then the series converges. So now, all right, well, what about this one? Well, first off, I can rewrite this as 1 over n to the 1, n to the 1/2, which is 1 over n to the 3/2, which is n to the negative 3/2. Add 1, negative 1/2, divide by that, I get integral is negative 2n. You know what? I'm being lazy. I want to show you the end of the story, but let's show you the whole thing. So that would be the limit, as we'll go with b, goes to infinity from 1 to b, n to the negative 3/2, which is limit as b goes to infinity of add 1 divide negative 2n to the negative 1/2. Hate it when I do that. From 1 to b, which is negative 2 over square root of infinity minus negative 2 over square root of 1, which is 2. So yes, it converges, but I will never do this again. 1 over n to the p. This is coming on the next page. If p is greater than 1, converges. That's really, really, really horrible. P is less than or equal to 1, diverges. All right, so this is the tipping point. 1 over n is my tipping point. Diverges. 1 over n to the 0.9, diverges. 1 over n to the 0.8, diverges. 1 over n to the 1.000000001 converges. Okay? Be prepared. That's everything. That's like everything we're going to do. All right, here it is. P is a real constant. If P is greater than 1, it converges. If P is less than or equal to 1, diverges. How much bigger than 1 does it need to be? Just a tiny bit. By the way, we call 1 over n the harmonic series. We don't call it that very often. I know I don't really bother. All right. So just a little bit bigger converges. That's it. Now this bothers people. They're like, but this goes to 0. The limit goes to 0 of the sequence. Shouldn't the series add up? Nope. Since the harmonic series keeps growing, it doesn't, when you add it up, series, you add it up, it doesn't tend to 0. So how long would it take to get to 20? So I'm saying 1 plus 1/2 plus 1/3 plus dot, 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 dot. And if it really does keep getting bigger, it eventually will get to 20. All right, well, let's see what happens. 1 to some number. I'll call it C this time. 1 over n dn equals 20. Well, that means natural log of n, 1 to c, equals 20. Natural log of c minus natural log of 1, 0, equals 20. E to the 20. Big. It's a massive number. Probably break your calculator if you put it in. Maybe, maybe not. Right, but it gets there. That's the point, that people get bothered. And this is why I actually put this note in there. For people who are always telling me, no, it doesn't get there. It doesn't have, yeah, it does. You can pick any number you want. It's just going to be e to that number. Eventually, it's going to get there. So this is our numero uno comparison test. I've said previously, everything's going to be compared to e to the x. Yeah, at that point in time. But when we're doing a test, it's all about the AP exam. It's all about comparison, right? So 1 over n diverges. So if you get 1 over the n to the 0.9, you're like, hey, it's smaller, therefore it diverges. 1 over n to the 2 converges. So those are the two we're going to compare to most often. I don't see this a lot on the AP exam. I may have seen, no, I've seen an integral test once on a free response question. I've seen a comparison test once on a free response question. It's pretty rare. I don't even think it was in the infinite series question. It was somewhere else. So determine whether these series converge or diverge. And I'm looking at this and going, diverge. And you're like, well, how can you just look at that and know? Okay, if we're going through this whole test, which I kind of blew off, whatever. The top would be a to the n. No, this whole thing would be a to the n. All right. So the thing I'm comparing it to is 1 over n, which diverges. All right. So they do the whole limit test, blah, blah, blah. Look at this. All right. Forget the 1, forget the 1. Eventually, this becomes what? 2 to the n over n squared, which is 2 over n. Even though there's a number up there, this diverges. It's 2 times 1 over n diverges. That's how I'm going to do it on AP multiple choice questions. Just going to look and say, yeah, that's going to diverge. All right. They do this whole thing, limit n goes to infinity, 2n plus 1 over n plus 1 squared. So we're comparing that, a of n and b of n, over 1 over n. You get the limit as n goes to infinity of 2n squared plus n over n squared plus 2n plus 1 equals 2. Now let's see what the rules said. All right, if you get between 0 and infinity, they either both converge or both diverge. That's pretty cool, huh? If it's 0, yeah, if infinity, yeah, whatever. Stupid. Again, I'm showing you how you're going to do it on a test. So since 0 is less than 2 is less than infinity, both diverge. You know, how boring is this? I want to kill myself. Pardon me, that's not polite to say. So keep going. Hey, it's a test. It's an AP test, multiple choice. Converges. This is basically throughout the one eventually, 1 over 2 to the n, which is just 1/2 to the n, which is a geometric series with an r of 1/2. It's going to converge. Okay, a over n. We'll go with a b over b of n, which is 1 over 2 to the n, and then we do the limit. You know, I mean, sure, whatever. If this helps you figure out what's going on, great. But 1 over 2 to the n, which is times 2 to the n over 1. Limit n goes to infinity, to the n, to the n, oops, plus negative 1, which is 1. 0 is less than 1 is less than infinity, so this one we know converges, geometric, yada, yada. So we can go up here and write converges. To repeat, I would never in a trillion years do this. Even if it was on a AP exam, I would say, when using the comparison test with 1 over 2 to the n, we see it converges. Done. That's what I would do. I wouldn't show all this nonsense. I mean, if I was there and I had the time, maybe I would. I don't know. I'm not doing that again. You can write it out if you want, but I mean, I'm just going to look at this and go, this is the equivalent of 3 over n squared, converges. Sum of sine over 1 over the n, that goes to sine of 0. This one is a little trickier. I'm going to have to do some math on it. All right. So let's go with, this is a of n, and b of n is 1 over n. Let's compare it to one we know diverges. So the limit, n goes to infinity, sine of 1 over n over 1 over n. Infinity 0, L'Hopital. Let's see. Oh, I cheated when I did this last time. That's horrible. Cosine of 1 over n times negative 1 over n squared, and negative 1 over n squared by limit as n goes to infinity, yada, yada. Limit as n goes to infinity. Cosine 1 over n. Cosine of 0 equals 1. 0 less than 1 less than infinity. Yay. Diverges. All right. Notice this one I didn't know. I've never seen this on an AP test. It's always this stuff. They just want to see if you remember the harmonic. Tricky stuff. So let's tie this in, oh, for goodness sakes, with alternating series. And eventually get around to that whole endpoint thing, which is the title of the unit. One of my pictures just fell off the wall behind me. All right, so I have been waiting for this one. This whole non-negative thing comes into play where they talk about absolute convergence And they talk about conditional convergence. Why do they got to make a difference between this? So you look at this and you say, there's alternating here, but this is just 1 over n. That's got to diverge, right? It converges. Because it alternates. Let me try and show this. All right. 1 over n, 1 plus 1/2 plus 1/3. It keeps getting bigger. We showed this. It goes on forever and ever. That we get to 20 or a million or a billion, whatever. It keeps getting bigger and bigger. That's adding. Add 1, add 1/2. What about -1? Careful here. It's not just negative. It's alternating. Well, check this out. 1, 1/2, 1/3, 1/4. Because they alternate, it's getting closer and closer to some number in here. So we call this conditionally convergent. Only made it because of the negative, right? It's kind of like some people in my class. How'd they get an A? They got a conditional A. What does that mean? They only made it because of the final exam. That's a really horrible metaphor. But anyway, all right, what about this one? -1 alternates, yay. 4 over 2 to the n. This is going to converge no matter what. Why? Because it's a geometric. If the value of r is less than 1, converges. It converges absolutely, converges everywhere absolutely. It's not a problem. Hey, this alternates, Mr. T. It must converge by getting no. It's not 1 over n. 1 over n alternating. Not 1 over n negative, alternating. This just diverges. Just getting bigger and bigger and bigger. Yeah, but you said if it alternates. I never said if it alternates. I said if it alternates and it's 1 over n. So this is all written out here. I have seen problems that use this. Kind of annoying. All right, it says if the terms, when I don't have alternating, are all positive, so I don't have negative, negative, and negative, 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 and all this nonsense. Sure, whatever. They always are. If eventually each term starts getting smaller, each term gets bigger. It can start, bigger and then eventually start getting smaller and smaller. Right here, it's getting bigger. Right here, it's getting even more small, but eventually the terms start getting smaller and smaller. And the limit of these terms goes to 0. That's kind of obvious. They have to. We've talked about that before. All right. So I will show you the AP question. I'll try and do it ice cold, see if I get it right. I often get it wrong. It's tricky stuff. All right. So what the hell does that mean? Well, I told you when we did Taylor theorem error series that it didn't mean anything unless we have an alternating series, because we don't know how much bigger this is getting and that it's going to get there eventually. We are now able to find a truncation error. Notice when we do this goofy little thing here, I don't know why I'm putting a vertical line, goes out to 1, and it goes back to 1/2. And then back and forth. Notice I say, well, how much error is there? Well, this one goes 1/3, and then everything else goes underneath. Notice if we just took the first two terms, the 1 and the 1/2, and then I said the error is the 1/3 term. The next term, it's bigger than all the other terms put together. That's what's going on here. Find a bound for the truncation error for 99 terms. We just use the 100th term. All right. Well, let's just make sure we're happy with this. It would just be u of 100. Assuming this is a u, bunch of u terms. Well, for example, 1 over n, that's positive, going by the rules from the previous one. And then U of n, each one's get it is bigger than the next one. And then the limit, even though it's an alternating, is the harmonic series without the, if it were not to have the alternating aspect, the limit as we get to infinity is 0. Cool, fits them all, it's alternating. The error is going to be the next term, the 100th term. So 99 go to 100th, and that would be 1 over 100. That'll be bigger than all the rest of the terms put together. Freaked out, not sure what the hell's going on? That's fine. Neither was I the first 4 or 5 years I taught this. Not even 100% sure now. But here we go. There it is, what I just said. Conditionally convergent. Yeah, you only made it because, you know, we're being nice to you. I don't know why they do that. Bugs me. Anyway, so what do? Use the ratio test. Whenever they're asking for an interval convergence, you're going to do the ratio test. Hey, you look at it and you're like, this is obviously geometric. Then okay, fine, do geometric. But you're going to do the ratio test. All right. If you get -6 to 4, -2 to 8, you know, whatever, test at the endpoints. Damn, those endpoints again. It's just like finding maxes and mins on the AP test. The ratio test doesn't work at these points. What does that mean? It means it equals 1. So you're kind of like, huh. So you use a comparison test, the interval test. Yeah, no, you're going to use the alternating series test. Period. End of story. If the interval of absolute convergence is in there, I don't know what the hell this is talking about. Yeah, this is just weird. We're going to ignore that. Okay, then. So here we go. This is it. This is the big all put together for the unit. We're going to do a ratio test. Limit, and notice this is why we put those absolute values on now. N goes to infinity. U of n plus 1 over U of n. This is the ratio test. Limit, n goes to infinity. All right, here's the term. Ignore this, right? X to the 2n, gracious, plus 1 over 2n plus 1 times, really only needed this on the top, times 2n over x to the 2n. Don't need absolute value at all because it's 2, but I'll put it in there anyway. I can't help myself. Okay, 2n, see ya. 2n plus 1 is x. Very cool. Yeah, what the hell just happened? I have no idea what just happened. Oh, by the way, it's x squared, my bad. Because that is n plus 1. So that means this is going to work as long as x squared is less than 1. Well, what are the absolute values? Well, it's squared, so I can throw them out. Square root. Oh, that means the absolute value is less than. This is getting weird. All right, which means -1 less than x less than 1. Woohoo, we're done. We go home. No, we're not. Okay. You ready? Hang on tight. Put in the endpoints. -1 squared, that's going to be 1 over 2n. It's 1/2 times 1 over n. Okay, so let's try that. Just putting in -1. We get -1 to the n plus 1, -1 to the 2n. Right, that's just going to be 1 over 2n. Well, that's like a 1/2 out front of an alternating series. -1 works. Okay. Let's try 1. We get -1 to the n plus 1, 1 to the 2n over 2n. Let's throw that 1/2 out front. We get, that's just 1. Alternate. 1 also works. Excellent. So the interval of convergence, -1 less than or equal to x less than or equal to 1. Conditional convergence at x equals plus or minus 1. Absolute convergence, -1 less than x less than 1. Holy cow, you can't be serious. No, we're serious. All right. It is. It's a headache. There's no question about it. All right, here we go. Ratio test. Limit n goes to infinity, 10x n plus 1, n plus 1 factorial. Oh, by the way, factorials can converge everywhere. Done. Oh, you got to be kidding me. You can't just, yes, I can. N factorial is going to converge everywhere. Think so? Yeah, I think so. N factorial over 10x to the n. Limit n goes to infinity. You'll have an extra n on the bottom. You'll have an extra n plus 1 on the bottom. And you'll have a 10x to the first on top. Do I still need my absolute value? Yeah, actually I do. 10, x over n plus 1. Oops. Okay, well, as n goes to infinity, I don't care what I put in for x. This is just going to get bigger and bigger and bigger and bigger and bigger. But in a billion, eventually, this will catch up and pass it, and this will become 0. Good news, don't have to do all this weirdness again. Converges absolutely for all x. The radius is infinity. The interval of convergence is negative infinity, less than x, less than infinity. You'll see in a lot of my notes I wrote the this thing. Remember, I said I can go either way. I don't care. And when is it conditionally convergent? None. Nowhere. No values. Doesn't exist. Cool. All right, looking at this one. Well, I'm not going to have an interval because I got a factorial on top. So something weird is going to happen here. It might just work at like one specific spot, like at -1 or something like that. So let's give it a shot. Limit n goes to infinity. N plus 1 factorial. I'm going to jump into the next part, n factorial. X plus 1 to the n plus 1. X plus 1 to the n. Yeah. Equals limit n plus 1 and goes to infinity. X plus 1, done. Absolute value technically. All right. This only gets to 0 if I plug in -1, because this gets bigger and bigger and bigger. That times 0 will be 0. Hey, I thought you said infinity times, yeah, shut up. So the radius of convergence is 0. The interval of convergence is -1. It is absolutely convergent at -1. And where is it conditionally convergent? No values, or none. Crying it? Almost there, I promise. Here is the problem you're going to see on an AP exam. Huh. Funny, never noticed that mistake before. D. Alrighty, this is what you're gonna see. So same as always, n goes to infinity. Absolute value x minus 3 to the n plus 1 over 2n plus 1 times 2n over absolute value x minus 3 to the n equals limit as n goes to infinity. Cancel, 2n over 2n by absolute value x minus 3 to the 1. Therefore, -1 is less than x minus 3 is less than 1. Plus 3 plus 3 plus 3, 2 less than x less than 4. I think we're done. We're not. Got to check the endpoints. So ready? This is where it becomes a lot easier for me, and I don't write this down. 2 minus 3 is -1. -1 to the n. Hey, it's alternating. It's 1 over n. It's 1/2. I don't care. Ooh, that works. 4 minus 3 is 1 over n. Yeah, no, that doesn't work. So, gotta write all this crap down. Interval of convergence, 2, 4. Absolutely convergent, 2, 4. Conditionally convergent at 2. Radius of convergence. Don't think they've been asking for that, but I think we've been writing it down, so might as well be clear. Confused yet? Good. Hey, this flow chart, no, this is really dumb. Don't worry about this. You're going to be doing that up there. Ratio test, because it's going to ask you specifically for interval of convergence, and then off you go. This right here is as hard as the alternating series gets on the AP exam. So hopefully that helps. But and one more time, just to be clear, I've been using these tests to say, hey, converges, diverges. We don't even know what it converges to. This remainder estimation theorem can tell us how big the error is. We still don't even know if it converges. Yes, it converges to what we don't know, but within this amount of error, that's, yeah. Hope you've enjoyed your year in AP Calculus, BC Calculus. Have a good one.